Okay, so in the last video, we discussed a simplified version of our vase to point out that in the sketch, not only do we have to fully define each point, right? We have to fully define the sketch, but we have to define the points in a certain way. As a quick review, if I open up the sketch from our last example, the points on the outside had to be dimensioned off of the bottom point of the outside, or the bottom point of, this isn't a spline, but in our base example it is. So it's analogous to the spline. We had to dimension them both vertically and horizontally with respect to the bottom part of the outside of the base. And the reason for that is we wanted to manipulate the bottom dimension, the base dimension, without changing the outside shape. By defining them to the bottom, they are rigidly, set in place, if you will, maintaining, for example, this is 30 millimeters above, this point here is 30 millimeters above the bottom of our base and 20 millimeters to the right from the bottom of our base. And it will always be that no matter what we do to this base dimension here, for example. So we covered that. Now we're going to open up a new design. I'm going to create a sketch on the front face, and we're going to go over a very simple spline. Okay, it's only going to have one point in the middle, if you will. So it'll be 3 points total, 2 endpoints and a point somewhere inside. And we're going to go over fully defining that in the same way as we did in the first video, right? Where we want the same outside curve independent of the base. It's the base radius, okay? Or the vase radius, the base of the vase. Okay, so just like last time, we want to close our profile to begin with. Okay. Let me go back real quick. I'll show you kind of what I did there. So if I want to be horizontally aligned to the top here, what I did is I took my cursor over and just touched, it snaps to this top part of the spline, and then it'll stay snapped to it as I move horizontally back over to my vertical axis, and then it'll snap to 90. So that's all I was doing there. And it will automatically add the constraints that I want as well by doing that. All right, so here we are. The first thing we want to do is add our base dimension, because we want that to be variable. So instead of clicking up sketch dimension here, I'm instead going to click D. It'll do the same thing. That's our hotkey. Okay, and let's make this a little bit narrower, 50. And because nothing else is defined, it's changed our curve. That's okay. Let's actually say, let's make it more of like a bowl. Okay. Let's go ahead and dimension, much like last time, the other points of our spline with respect to the bottom point on our spline. And we're doing this for the same reason that we've discussed several times now. We want the outer shape to be the same. When we change the base dimension. So this point, let's see, I'm going to change this just a little bit here to make it aesthetically look like I want it to. So this point here will always be 25 millimeters above the bottom point of my spline, and it'll always be 30 millimeters to the left of the bottom point of my spline. Perfect. If that's the case, it should maintain the same shape no matter what. I'm going to do the same with the top point. 10 millimeters to the left and 55 millimeters. Okay, so we're at the same spot that we were at with our simplified version of the vase, where we weren't using a spline, we were just using straight line segments. Now I still need to understand why it snapped to black, because we're not fully defined yet. I'll have to look into that because it should not be black. We're going to go ahead and define the angles of our handles first. And what I'm going to do in this particular instance, and you don't always have to do this, you can define, you'd be fine to define our angle by clicking on the handle, clicking on some horizontal. It doesn't even have to be this bottom x-axis, right? Like I could come over here and, click on my handle and click on this horizontal and define angle off of that. But I'm going to do something else instead in this particular instance. Let's say I want a really nice smooth transition from my curve to the top of my boulder, the top plane. I can come up here to my tangent constraint. What that means is at this point, the spline will be tangent to, right, or in line with the top of my vase. So I'm going to click that, and there it goes. It's tangent at this point. I can do the same to the bottom of my spline. And what I've done is I now don't have to define the angle of the handle on either end here. Maybe this isn't the shape I want, but we'll leave it there for sake of using the tangent constraint. It's not really a bowl anymore. It's like a disc. So you can see that when I click on this, the handle is, as it should be, tangent to, or in this case, horizontal with the top, and it's also horizontal with the bottom here, so we don't need to define its angle. But we do need to define its magnitude. Let's make it 10 and see what that does. Yeah, a little better. That's effectively making the radius smaller. Might get us closer to that shape we wanted. So we're defining the magnitude of the handles here. I'll make that 3. Okay, it's an ugly shape, but it's fine. Okay, we're close. We are close. The only thing that's left is this handle here, right? You might have noticed that the handles disappear when you have deselected the spline. So you actually need to click on the spline to see those handles. I will define this angle. With respect to our horizontal. And I just gave that some magnitude. It doesn't honestly matter all that much. Okay, so the only difference in comparison to this and the previous example where we just had 2 line segments instead of a curve or a spline, the only difference is now we not only have to define the vertical and horizontal components of each point on our spline, we also have to handle the angle and the magnitude of the handles on each point, okay? So if we count that up, each point has a vertical component to its position, a horizontal component to its position, a magnitude to its handle, and an angle to its handle. So 4 things that you have to define at each point. In this particular case, we were able to define the handle location on the top and bottom by using a tangent constraint. So we didn't have to input or dimension, say, an angle. Cool. So if we did this right, we should be able to change our base and maintain the same outer curve, like so. Let's go into 30. Once again, we have not changed the outer shape, but we've changed the base dimension, which is great. I'll finish my sketch. I'll click revolve, just like we did before. And it's already highlighted my profiles, so I'll click on the edge that I want. Click OK. Ah, it turned out nicer than I thought. Shell. And I thought that might be an issue. So because this curve is tangent to the top plane, when I select this object, there's only one face. The whole body is one face. So it doesn't know which side is, say, the open side, right? Like which side needs to be hollowed out. And that's what I believe this tangent chain toggle is. But I'm going to need to play with this a little bit. And we'll come back to this example on how we might hollow it out if it's one continuous face. Okay, I did a little bit of analysis here on our shell function, right? We have a single body that effectively has one face because we have a tangent at the top and bottom, and so there's not multiple faces to this object. So when we click shell and we hit this, it doesn't know which part of the vase we want open. If we go ahead and roll through the shell command, let's say we give it a 2mm wall. Ooh. Let's try that again. I hit tangent chain there. There we go. It has effectively hollowed it out. Hold on a sec. Well, it hasn't hollowed it out. It has hollowed it out, but it's still a closed face here. And the reason we know that, even though we highlight over it and it looks like we have an open top here, it's actually just highlighting the bottom surface. But to know exactly what's going on here, I'm going to click on Inspect, Section Analysis, okay? And then I'm going to select my XZ plane. The way I did that, the way I highlighted the XZ here, because before this wasn't popping up, I can click and hold, and then I can toggle between the different choices around where my mouse was. So I want the XZ plane. So again, this was Inspect, Section Analysis, and then I clicked a plane that I wanted to view a cross section of my part from. And what's really cool about this is I can actually take this arrow and I can drag it forward and backward to see various cross sections at different planes that are parallel to the plane that I originally selected. But the point I want to show here is the shell command. When you have an object that has one face that kind of wraps around its entire body, the shell command still works, but it hollows out the part and doesn't give it an open face. So what we have to do if we want an open face on this part is we have to go back, and for, on the top here, we can't have the curve, we cannot have the curve tangent to the top face. We need to define the top face from everything else. So I'm going to exit out of our section analysis. Okay. I'm going to delete my shell. And then I'm going to right click, edit profile sketch. And this is what we're concerned with, is this tangent. So I'm going to click on my tangent constraint and delete it. I might move this guy off of horizontal, and then I'm going to give it a dimension. Okay, so now we have a defined top face, and you can actually see that, I've highlighted over this here, and it's defining this top, or showing this top face is separate of the rest of the body. So if I did this right, let's hope I did. I'm going to select this top face, click 2 millimeters, and sure enough, it knows that we want it hollow with this face or plane open. Cool. So just for review, I won't drag over. We started in the simplest of terms, okay, where we defined an outer geometry that was independent of our base dimension, our base diameter, or our base radius rather, in the sketch. And we didn't have to worry about angles and magnitudes at each point. We just had to define the points with respect to the bottom edge. Okay, we made it a little bit more complex with a 3-point spline, which is the simplest type of spline. Okay, but we did have some angles to define at each point for the handles, and the magnitude of each handle. And we realized we can utilize tangent to define angle on a handle, but we also realized that in order to use the shell tool, at least with respect to a vase or a bowl or something that has an open top, we have to define that face has to be independent of the rest of the body. In other words, we cannot have the spline tangent to the top face. So the next video, we are going to make a vase with more than 3 points, right? With 2 points in between the top and bottom. Okay, it's going to be a little bit more complex, but we're just going to use the same principles that we've applied in the last 2 tutorials, or the last 2 videos, to this, and we should yield the same results. Where our outside curve remains the same as we move the base in and out.